Okay, part two. This question, I know at the end actually. This question, we're looking at the distance. Trying to work out this line. You should be thinking to yourself when I'm told about calculating lengths of lines, it's going to Pythagoras or trig. With no angle, it's going to be Pythagoras. And all we have to do is turn this into a right angle triangle. So a right angle sits in here. And there's my right angle triangle. And all I have to do is count the boxes. So 1, 2, 3, 4, 5, 6, 7. So 7 boxes along the way. And there's 3 boxes up and down the way. 1, 2, 3. The right angle is here. And opposite the right angle is the longest side, the hypotenuse. So that means it's going to be Pythagoras. And so 7 squared plus 3 squared is equal to x squared. So that means that 49 plus 9, so 58, is going to be equal to x squared. So x is then just equal to the square root of 58, because I want to square root both sides. So square root of 58 is 7.6. I'll just leave it at that, 7.6. And I'll say units or squares or something like that, okay? Because there's not a distance, but if we said units or squares, that should be okay. So that's a Pythagoras add. Now, say you weren't sure, and you did Pythagoras takeaway, you'd end up with a number like 4 or something, okay, as your final answer. Can this longest side be 4? Does it even look like 4? No. Right? So you can't really get wrong. You have to have, you can't really get it wrong. If you do the add, look at the number, 7.6 is bigger than 7. If you have a number smaller than 7, you're thinking, I've made a mistake. So you just can't get this wrong. Okay, do your Pythagoras add, because you're finding the longest side, but do a sense check at the end, and then if it doesn't make sense, do the other one. Good stuff. Number 11, we've got an angle and a right angle, so we should be thinking trig. So here's my angle, and I'm going to label up my triangle based on that angle. So this side is opposite the angle, and this side is adjacent to the angle. Now some people might have said, oh, this is adjacent to the angle. Well, it is, but it's also opposite the right angle, so that is the hypotenuse. So it can't be the adjacent, it's got to be hypotenuse. And now we say, what are we looking at? Well, we know the hypotenuse, and we know the adjacent. So is that going to be so, ka, or toa? So it's not so, it's ka, adjacent hypotenuse, and it's not toa, just to double check. So I'm going to say that cos of x is equal to adjacent over hypotenuse. So cos of x is equal to 7 divided by 12. How do I get the x on its own? Well, some people would say divide by cos, because you're multiplying by cos, but you're not really multiplying by cos, you're putting x into cos. So it is a function, so we need to do the inverse of that function. So it's cos negative 1 to the 7 over 12. And all that means is shift cos. So on your calculator, the opposite of cos is shift cos. So I'll do shift cos of 7 divided by 12. And that's going to give me 54 degrees. I'll just round it to 1 degree. 54 degrees. Simple. So label your triangle up, decide if it's sine, cos, or tan, write your formula, substitute in, and then you might have to rearrange slightly. This is probably the harder rearrange, doing your shift cos. The next one, driveways, ramps, I love it. This is a classic question, so I'm just going to highlight my key information. Got 3 meters long, 18 degrees, calculate h. Okay, so there's the h, there's the 3, there's the 18. So we don't really need to know anything. I don't need to read into this anymore. The diagrams here, we're calculating for h. So let's label up our triangle. There's the 18. This is opposite the 18. This is adjacent to the 18. And this is the hypotenuse. This is opposite the right angle. So I have an opposite that I'm trying to find, and an adjacent that I know. So it's going to be tan, isn't it? Toa. So tan x is equal to opposite over adjacent. So tan of 18 is equal to h divided by 3. How do I get h on its own? Well, I'm dividing by 3. So if I times both sides by 3, it gets rid of the 3 on the right hand side. So 3 times tan of 18, and that's h is equal to 0.97 meters. The second part of the question says, would the driveway pass regulations? For the driveway to pass regulations, it rise by no more than 1 metre with the driveway pass regulations. I think that's kind of worded poorly. I think it's meant to say the rise is no more than 1 metre, and the rise is this value here. So you would say that yes, it meets the regulations, and 0.97 is less than 1. The wording of that's a bit off. So put your answer and then justify it. Yes, it would pass. 0.97 is less than 1 metre. And our very last question, we're on to scattergrams. So a restaurant manager finds that the cost of running his restaurant depends on the number of meals. Obviously, the more meals he serves, the more it's going to cost. So we're going to plot that in a graph. So we've got meals along here, and we've got the cost up here. So 10 meals, 125. There's 10, and there's 125. Note that the increments along here are in 5s, and the increments up here are in 25s, because I've got 50 in 2 increments. 50 divided by 2, 25. 20 and 175. 30 and 175. 40 and 225. 50 and 225. Those are the 40 and 225 should just be over a tiny bit. And 60 and 275. So 60 and 275 would be up here. So 60, 275, that looks good to me. 50 and 225, 40 and 225, 30 and 20 are both 175, yep, and 10 is 125. Okay, excellent. So to draw the scattergram, we've just done that, and now we're going to draw the line of best fit. So I want a line that roughly touches as many of these lines as absolutely possible. Now, anything I think round about here, I'd say anything about here is looking good. That's not too bad. See, quite a nice pattern actually, where all these numbers are quite close to the line. Okay, yeah, that looks good to me. So best fit, we're touching, getting as close to as many points as possible. For example, this is rubbish. It's not anywhere near these points. Okay, if we're down here, we're not anywhere near the points. But the minute we go through here, this isn't even that good because several of the points are below, several of the points are above, and now we've just got this sweet spot where a few are above and a few are below. And now we're going to use that to estimate the cost of running the restaurant when 55 meals are served. So where's 55 meals? It's down here. So I'm going to go up to here and go along. So it's going to be 250. Okay. So if I've got 55 meals, it's going to be 250. That's all the line is really. It's like if you kick a ball off a wall, it's kind of where it bounces back to. And this is just bouncing our data from here along to there. The restaurant owner estimates the cost of running the restaurant when 75 meals are served would be 300. Is this reasonable? So now we're going the other way. Well, we could actually go either way, but we'll do it the other way. So £300 should equate to 75 meals. So I'm going to have to extend my line over slightly, first of all. So £300 is up here. So I'm going to go along 300, and I'm over about here. So if I go down, that takes me down to 75. So that is very reasonable. So yes, that's reasonable. And make sure you show on your graph the points that you're looking at as well. So 300 does equate to 75, and before we said 250 equated to 55. And that is everything on relationships. So a bit more of a whirlwind tour than the last one. But if you watch the first one, I'm sure you'll be starting to get into the swing of things. So try the third one yourself. And the marking scheme is at the back. Thanks very much.